Alright, hello everyone, it's Mr. Barden here. This video is going to be focused on the coding portion of the pulse width modulation section of this course. So I'm going to be focusing again on just the code. This is kind of the raw video. I will be combining everything in post. You'll see another video that I'm posting online with this little rig that you actually can't see because I don't have that camera hooked up, but I've got a little tripod here so we can actually see the circuits that I'm building without me having to hold my phone and talk and build all the stuff on my desk. So those will be coming out relatively shortly. Again, this is just the code portion, and with the magic of video editing, you will see all of these combined. I'm putting everything online so that way that no matter what, the people who need to see it can have it. But I am aware it's a little disjointed at the moment. That will be coming out hopefully this weekend, but pretty soon with all of the combined slightly longer videos. But with that being said, let's just hop into it. So what I have here on the computer is a code. It's what we worked on before, where we worked with the digital inputs and outputs. Um, Actually, not the digital, the analog. These are the analog. It says analog. But again, what we've done here with this, just to kind of catch you up, is we have hooked up a potentiometer to pin A0, and we are getting that value, and we're also mapping it somewhere else. And then we have an LED hooked up to pin number 8, and basically we are just we're utilizing that to kind of combine a few different things. So we're beginning the serial communication, and then we're saying that the LED is an output. In the loop, we're just reading that value from the potentiometer, and then we are mapping it to something else. We're then sending this out the serial port so we can see it, and we're also using that value to adjust the delay time between turning on and off the potentiometer. So let me get my wire here so that way um, we can at least see the serial port. So let me plug that into my Arduino. I know you can't see it. Don't worry, you'll see it in just a moment. But I've got here, if we go to tools, we make sure that we have the Arduino Uno. It's plugged into COM3. That's great. So let's open the serial monitor. And now it's going to talk. So we can see some of that didn't quite work out in terms of spacing. So I'm going to actually just remove that, and I'll put it down here, and we'll re-upload the sketch. That way it just doesn't look disgusting every single time. So I'll go back and we'll open up that serial monitor, and we should see that the potentiometer value is there. We can see the total percentage, and as I adjust it, it speeds up, and as I slow it down, it goes back down. Full disclosure, I don't actually have a potentiometer set up at the moment. It's still the photoresistor that I looked at the very end of last video. But you can see it's responding to the amount of light that it can touch. As more light enters the system, the delay increases. That's what we've got going on. But the reason I wanted to start with this is because from this point, it's a very relatively easy thing to do to swap to the pulse width modulation. And I've used that word a bit before. So let me actually pull up the textbook here and pull up a diagram. I think this will be very helpful for you all. So again, everything I'm talking about is here in the textbook section. You'll notice that pulse width modulation is still in the same section as analog, because it's technically analog, but it's also it's like in the middle, a combination of both of them. So basically what's happening, what we're going to be doing, is causing the light to blink on and off, just like this. And I'm going to cover it up again, but I'll leave it for a second, so it may blink a little fast. I am warning you now, photosensitivity, this blink speed will increase. That's about as good as I can get it with this particular sensor on, but I've got one up here in a video that does the same thing, but with the potentiometer. So you can explore that on your own if you want. But if you remember from before, the in the digital I/O, an LED is a digital component. It only has two states, on or off. There are no other options. But we can mimic those other options by taking our LED. That's not an LED. By taking our LED, and we can turn it on and off extremely fast. This is faster than the human eye can tell. It's happening extremely fast. But because it's happening too fast for us to be able to tell a difference, we can use that to manipulate its perceived brightness. So again, we're going to be doing this same thing, only much, much, much faster. And in order to kind of talk about this, we have pulse width modulation. So if you think about every time we turn on the electricity is a pulse of a pulse of power going through, and then if you look at it over time, the percentage that electricity was on is the duty cycle. That's the width of this pulse. If we look at this is time horizontally. So by having it on for 75% of the time, it'll average out, and through our brain, kind of smearing things together that's too fast for it to interpret, it will look as if it is 75% of the volume, so, or the brightness, because it's on, but it's only on 75% of the time. It kind of lights up that way. So I've got the tutorial for what I'm going to do all listed out here, but I'm going to just walk you through it. But so if you wanted to look through this, there's some more info. So in terms of the code is really, really simple. So I'm going to get rid of I'm going to first file save as. Let's save it as a Arduino there we go. Okay, so there's that. So now that I've not overridden my old stuff, I'm going to delete this part with the delay. We don't need that. I'll keep this bit right here. But there's a few things we can do. There's a reason I mapped this automatically. We can find mapping that will be pretty helpful. But we'll map it to a few different ranges, actually. So let's go int RGB pot. I'll leave it like that, equals 0. And then basically I'm just going to map this to a different range so we can see some of the differences. So 0 to... All right, there we go. And then... All right, so I've got this listed a few different ways because it's going to be the same incoming value, but we're going to map it to a few different things. We can see a total percentage of the maximum brightness, as well as if we were to map it to that RGB value, which is a refresher. RGB goes between 0 and 255 on the far ends of it. So that's why I've mapped this twice, so we can see what works better or not for our code later on. So all we have to do now is do some tweaking. So right now our LED is connected to pin number 8. Normally I would make some adjustments with this in the circuit part of the video, but I'll mention it now. Whenever you want to do the pulse width modulation on Arduino, you need to look at your digital pins. Okay, and on the side it will say PWM with a little squiggly mark. So any of these pins that have the little squiggly mark before their number are the ones that you can use for this. So on the Arduino Uno, that is pin number 3, 5, 6, 9, 10, and 11. Any other ones, this will not work. It has to be with the little squiggly output. So I'm going to change this LED to be pin number 10 on mine. And then we'll have to change that in the code to be a pulse width pin. Other than that, that's pretty much the only thing we have to change. The only thing that's different is that now in order to send out that electricity, we have to say analog write. And again, this is a function for writing this pulse width modulation data. It's the only way we analog write, and it has to be one of the pulse width pins. Otherwise, it won't work. So we'll write to the LED pin, and we'll send the mapped pot value out there. So let's just send it. It is done uploading. Cool. So let's look at it with the numbers first, and then I'll break down the circuit bits in the other video. So if we open up that serial monitor again, we should get 3 things. That's happening extremely fast. So I'm going to make it stop auto scrolling, but we can see that we've got that pot value, we've got that percentage, and it's mapped to that RGB. Just generally looking, we can see, because I've still got the wrong sensor hooked up, it's not super accurate, but as I cover this, that LED dims, and actually I can get it really dim, and then it'll brighten up when it's exposed to light. So we can use that to control the perceived brightness. Again, what is happening is we are turning it on and off a lot, way faster than we can see. We are just perceiving it as being 75% on. In fact, if I, again, opened up that serial monitor, again, this time I'm sending out the RGB value. So it's an RGB, I think, a 72. If I close it, brighten it, you may get different brightness results, but I'll turn back on auto scroll and kind of do this a few times. And then we'll turn it off, and you can see that this is changing those values as we go along to get brighter or dimmer lights. So again, we're just changing how fast it is blinking. You can stare at it. It's not going to hurt your eyes or anything more than normal, but it is just turning off and on way too fast for any human to be able to see. If we had a super, super, super high-speed camera, we could probably slow it down enough to be able to perceive it. But the whole point is that because it is too bright to be able to tell a difference, we, as humans, are seeing it as a single brightness. So pretty much anytime you see an LED that can change its brightness, that this to some degree is what is happening. Again, I'm speaking very broadly, but generally speaking, this is how you can control the brightness of an LED. Okay, so that's going to wrap this up. Again, I'll have a separate video coming out that will break down the circuit in a bit more detail, and we'll use actual potentiometers and exploring this code. With that, I'm not going to be working with this code outside of any, sudden tweaks that come across. I'll make sure that gets uploaded to the board, and I'll have all of that recorded separately and put up here as well with this video. I will then, I've got one more kind of 2-parter to record. That one may not maybe 3 parts, but one more to record, and then I'll be editing them all together. So you'll have a more cohesive run. I get that this isn't the most, this is a little bit jumbled of a way to organize all of this, but I'll be out of town very shortly, and I wanted to make sure I at least had all the parts available, so that way I can do all my editing on the road if I needed to. I wouldn't have to worry about recording anything while also traveling. So that's going to be it from me from right now, and I will see you all the next time that I see you. Bye.